All right, in this video, we're going to take a look at using the definition of continuity to analyze a piecewise function. The important thing is if you're watching this and you're preparing for something like the AP exam, you just want to take note of the fact that you want to be using the definition of continuity in order to do this. Okay, the graders are going to want to see that you know the definition. So let's remind ourselves of the definition, or the test rather. So the test says that we need, first of all, for a function to be continuous at a particular x value a, we need the function to exist there. Oops, that's not what I meant. We need this to exist. We need the limit as x approaches a to exist. Okay, and then the last thing we need is that those things agree. So they do to exist and also agree. So we need that the limit as x approaches a to equal the value there. All right, so as we analyze these piecewise functions, we're just going to bring out the aspects of this test to analyze these functions. So this question says, is the function f of x, defined as this piecewise function, continuous at x equals 2? So we apply the test. First, we need to see that f of 2 exists. So f of 2 is, according to this piecewise function, because it's defined as 6x minus 3 for x greater than or equal to 2, we substitute in 2 for x for the bottom piece. The value of the function, therefore, is 12 minus 3, which is 9. Okay, now we look at the limit as x approaches 2. The limit as x approaches 2. Well, with a piecewise function, you're going to need to analyze two aspects of this. So let's go over here and do that. So first we have to look at the limit as x approaches 2 from the left-hand side. As you come from the left-hand side, the function is defined to be 2x cubed minus 1 for x values on the left of 2. So we can use substitution there because that's a polynomial. Right, so we're just going to write the limit as x goes to 2 from the left, and that's defined on the left-hand side of 2 to be 2x cubed minus 1, so we can use substitution here. 2 times 2 cubed minus 1. 2 cubed is 8. 8 times 2 is 16. 16 minus 1 is 15. So the left-hand side of the limit is 15. At this point, I already know that it's not going to be continuous because the left-hand limit here doesn't equal the value of the function, and the only way for the middle thing to, the only way for this last thing to happen is if they would agree. But let me just, to be thorough in this second step, help you see how you would analyze the limit coming from the right. As you come from the right, the function is defined to be 6x minus 3. So we use substitution there. And that equals, so we plug in the 2 here, that's 6 times 2 minus 3, which is 9, okay? But because the left-hand limit does not equal the right-hand limit, the limit as x approaches 2 doesn't exist. And now we answer the question, is the function continuous at x equals 2? We say no, and the reason is because the limit as x goes to 2 does not exist. Okay, for the function to be continuous, all three aspects of that test above have to pan out, and it didn't. Let's try it on this example. So we test first that g of 1 exists. So what is g of 1? According to this function, it's 6 times 1 plus 3 because x is defined to be 6x plus 3 for x greater than or equal to 1. So this is 6 times 1 plus 3, which is 9. We test the limit as x goes to 1. So let's see, we have to test both sides now. Let's go over here and test from the left. The limit as x goes to 1 from the left-hand side of g of x is equal to the limit as x goes to 1 from the left-hand side. The function is x squared plus 3x plus 5 on the left-hand side. With polynomials like this, it's great because you can just use substitution here. So we substitute 1 in for the function, and we get 1 squared plus 3 times 1 plus 5, which is equal to 1 plus 3 plus 5, which is 1 plus 3 is 4, 4 plus 5 is 9. We look now at the limit as x goes to 1 from the right of g of x. And that is, so to the right side of 1, the function is defined to be 6x plus 3. So this equals the limit as x goes to, well, actually at this point we just substitute. 6 times 1 plus 3 equals 9. Those limits agree. The left and the right-hand limits agree, so therefore the two-sided limit is equal to 9. And therefore our punchline is that we know that the limit as x goes to 1 of g of x is equal to g of 1. And so this proves that the answer is yes, g of x is continuous at x equals 1. One subtle point before I move on. Over here, right, when I evaluated this by substituting 1 in, you have to understand that's technically different than what I did up here. G of 1 is defined to be 6 times 1 plus 3. Over here, I was evaluating a limit for x values that are approaching 1 from the right-hand side. And as it turns out, that function is just 6x plus 3. So even though I plugged 1 in both cases, I was technically doing something different. That's just an important thing to notice. But in any case, that is how you would test continuity for a piecewise function.